we are going to start off the day by talking about a biconditional statement. So, a biconditional statement is a statement that contains the phrase if and only if. Okay? So that is our key vocab word of the day. A biconditional statement is a statement that contains the phrase if and only if. So that is the straightforward, straight up definition for a biconditional statement. Okay? There is a very cool, very slick, easy way to write down a biconditional statement, and it looks like this. It's called IFF, and it stands for if and only if. Mikhail, you pay attention? Good. If and only if, okay? So you don't have to write down the if and only if every single time. You can do the cool little IFF thing, okay? Now, biconditional statements, just like yesterday when I was talking about definitions, how some definitions can work forwards and backwards, right? Just as the perpendicular lines. Same thing for biconditional. It means that it works forwards and it works backwards. It can work both ways. So that's very, very important. Okay? Okay. So rewriting a biconditional statement. And again, there's that word, biconditional. What is it again? It's a phrase that has what? If and only if. And what's the cool hand way of writing it down? IFF, right there. So you can do that, IFF. Okay. So rewriting a biconditional statement. So let me give you this statement right here, okay? A. It says this: an angle is a right angle. Okay, here it comes, IFF. If and only if its measure is what, everybody? An angle is a right angle if and only if its measure is what? Who can tell me? 90 degrees. Very good. Okay, very, very simple. 90 degrees, okay? And that is a biconditional statement because it contains the phrase if and only if. Do you agree with that part so far? Yes. No big deal, right? Nothing going on. That's too crazy, okay, right? So what I'd like you to do right now is I would like you to write down for me, please, the conditional statement. Okay? And I'm going to highlight that in purple over here, okay? Now, what's the difference between a biconditional versus a conditional? Who remembers what it is? Conditional statement has what? Say it again? Yeah, you're right. Say it again. Yeah, the if and the then part. So please right now, rewrite this biconditional statement into an if part and a then part. What? Okay, so I'll pause that for a second. So, if an angle is a right angle, then its measure is 90 degrees. Is that the correct way to take a biconditional statement and rewrite it as conditional? Is that right? Yeah, that is right. That is right. Okay, good. Now that we have this part, okay, a different way wouldn't be pertaining to this particular example. So conditional part has to be the first part of the sentence. Okay? So let's talk about the next part. Okay, I'd like you to write the converse. And I want to highlight this part in green. Okay? I'd like you to write the converse of your conditional statement. So it's an if and then a then. Great. So we have the converse now right there. So I'm pausing. So we have the converse says if the measure is 90 degrees, then it is a right angle. Okay, let's go back up over here to the conditional statement. Okay, take a look at the conditional statement, which is in purple. All right, read that conditional statement and ask yourself, do you think that statement is true or false? Just think about it right now. Is the conditional statement, the one in purple, true or false? True. Oh, you guys think you know already? Put your hands up if you think it's true. If an angle is a right angle, then it's measured 90 degrees. I would tend to agree with you, yes. And we can say that that is true because we have a definition that can back it up, right? We have a definition of right angle. The right angle must be 90 degrees. So by definition, this is a true statement. Now, please look at the converse, okay? Is the converse also a true statement? Yes. If a measure is 90 degrees, then it is a right angle, and we can back that statement up with a definition of right angles. So this happens to be true as well. Okay, where am I going with this, right? I'm going over here. A biconditional statement, biconditional statement is equal to a conditional statement plus the converse. Okay? So our biconditional statement, our original statement, was the one that was in yellow. So if I go back up there, it's right there. An angle is a right angle if and only if it measures 90 degrees. Okay? Our conditional statement was in purple, and then finally our converse was in green, right? Do you remember all the color schemes that we did? Okay. Now, we said this. We decided as a class that, that the conditional statement was true. And we also decided as a class the converse was true. So if the converse and a conditional statement is true, what does that tell you about the biconditional statement? True. Then it must also be true. You follow me so far? Now watch this. If your conditional statement is true, but your converse is false, what does that tell you about the biconditional? False. What we are creating are miniaturized truth tables, okay?
So they both have to be true for the biconditional to be true?
Jared, perfect. You hit it right on the head. They both have to be true. And when you say they, what do you mean?
Conditional and converse.
That's right. The conditional statement and the converse both have to be true in order for what to happen?
The biconditional statement.
In order for the biconditional, and that's the point I'm trying to make today. You guys follow me so far? Here is a biconditional statement. You attend school if and only if it's a weekday. How do you know it's biconditional? Yes, there is a statement in there that says if and only if, right? So oh my gosh, I just crossed it out. If and only if, right? There's the if and only if part right there. So it's biconditional. Okay, what I would like you to do right now, I would like you to scoot your desk close to somebody who's next to you and make a decision. Is this biconditional statement true or false? Okay, ladies and gentlemen, I'd like to unpause this. Right now, we just had a nice, semi-nice debate about whether or not we thought the statement you attend school if and only if it is a weekday. Regardless of whether you were on the true side or you were on the false side, can we all agree that we need some kind of a logical way to come to a conclusion? Do we all agree on that? That's important. I think that's important. Do you have something you'd like to say? Oh, you have a way to figure it out. Okay, I'm going to show you the steps that we need to learn to figure out maybe those steps align. Okay, here's the first one. Please write the biconditional statement as a Okay, I got this. If you attend school, then it is a weekday. Is that what you got?
Yes.
Okay, now we need to have a little mini debate about this. Is this statement true or false? And I would like to give you some parameters. Okay, I would like to limit school to Healdsburg High School. I would like to limit attend, means you show up and a teacher gives a lesson and roll has been taken. Okay, is this true or is this false?
True.
What do you think?
False. True. When there's limits, then true. What are you talking about?
If you attend school, then it's a weekday. I want you to all agree that this is true, right? Okay, so do we agree that this is true? Yeah, there is no Sunday school at Healdsburg High School, correct? So we all have now agreed that this statement is true. We're all on the same page, right? Okay, good. Now, please write the converse to this statement. Step 2. Write the converse. And of course the converse is if some stuff, then. Okay, I got this as the converse. Did you get this? If it is a weekday, then you attend school. Yeah. Is that what you got? Yeah. Okay, ladies and gentlemen, now we have to make a decision as a group. Is this statement true or false? Oh. Same limits as last time. Hillsburg High School, attendance is taken, a lesson is taught by a teacher. So is this false or true? Ooh. Ooh. Oh, okay. Okay, raise your hand if you think that's true. Raise your hand if you think it's true. Do you think it's true? Raise your hand if it's true. Raise your hand if it's false. So it looks like we are agreeing that this statement is false. Can you give me a counter example to support your claim this is false? Yes, Mr. Brem.
Holidays when you're sick.
Yeah. How about last Monday? What was last Monday? Labor Day. Were we here?
No.
Was it? We were here? I wasn't here. I was giving a lesson. Okay. Was it a weekday? True. Were we at school? No. So therefore, if it is a weekday, you attend school is false because we found one counter example. So now, check it out. We have just said the conditional statement is true, but the converse is false. What does that make our original biconditional statement? False. Therefore, all you falsers were correct. All you falsers were correct.